Our next form is called intercept form, and this is your formula. Now you'll notice something similar is that it still has an A, so your A does the same thing as before. You don't need to learn that over. You'll notice that this is set up in factored form, not standard form, not vertex form, but this is factored with a GCF in front and then up to 2 sets of parentheses. It's called intercept form for a reason. I want you to keep that in your head as we graph this. So what we're going to do is get it in factored form and then set each of them equal to 0. So what x would it take to make this 0? Well, x equals 6. What x would it take for this to be 0? Well, x equals 2. Now these are both x's, so don't tell me that this is 6, 2 or 2, 6. These are both x intercepts. Remember, this is the intercept form. Excuse the beep. So what I'm going to do is I'm going to plot a dot, just like a y-intercept. I'm going to plot it on the x-intercept, though. A 2, 3, 4, 5, 6. Now, what do we know about parabolas? We know that they are symmetric. So this has a symmetry point to here. So my question to you is, can we work backwards and find the axis of symmetry? Well, the axis of symmetry can't be here, because then it's 1 on the left and 3 to the right. Can it be here? Yeah, that's exactly in the middle. 2 to the left and 2 to the right. So what I'm going to do is I'm going to put a little marking here. Oftentimes use a different color or a dashed line, but that is my axis of symmetry. My axis of symmetry is that x equals 4. Well, do you recall that your axis of symmetry is also the x part of your vertex? So I know it's 4. And so where is my vertex? Well, notice there are no h's or k's. So my formula, my function is not going to tell me directly my vertex. However, if I know my x, how do I find my y? Well, you plug it into this y. So this has an unknown y equals a half. My x is going to be my 4. This x is going to be my 4. And watch this check step. Order of operations say do the inside first. -2, +2. Look at that. These parentheses will always be equal and opposite if you did it right. So I'm happy. I can move forward. Just going to multiply through. I get y equals -2. So I know I have a vertex of 4, -2. And we always like 5 points. So what I'm going to do now is I'm going to recall what my A does. My A is my 1, 3, 5. So my 1A says go right 1 up half and symmetry point. And 3A is 1.5. Go right 1 up 1.5. Hey, look at that. It hits. And now I'm going to remind you also, it's really easy to find the y-intercept. You just plug in 0. So this is not going to be symmetric. But what if I plug in y equals 1/2, 0 minus 6, 0 minus 2. So 1/2 -6 times -2 is +6. 1, 2, 3, 4, 5, 6. Is that a reasonable y-intercept? Do you think that if I continue on my 1A, 3A, 5A, I would eventually hit there? I think it's reasonable. Another good check. And there is my equation. Not too bad. Now, if you didn't already have it in factored form, could you write it in factored form? All you have to do is factor it. Take the GCF, pick your favorite method, and you're good.